Hi everybody. Today we're going to finish up tangents. So we're going to talk about a few other pieces of information regarding them. Here's the first thing we want to be able to do. We want to look at this circle here, right? Circle F, and we have radius FG, and we're being asked to determine whether or not GH or HG is a tangent when compared to circle F. And they already have it pre-drawn. They give us some measurements, and there's actually a pretty simple way to do this. And what you would do is you want to check to see if FG is perpendicular to GH. Because if it is, that means you're forming a right angle where at the point of tangency, where the radius meets the tangent. And if that's the case, going back to what we know about tangents, then yes, it is indeed a tangent. So how do you do this? Well, you just use Pythagorean theorem, because you can see here that we have the creation of a right triangle. So this would be the hypotenuse. This would be a and b, whatever. So a squared plus b squared equals c squared. We're going to see if this works. We're going to say 6 squared plus 8 squared equals 12 squared. 6 squared is 36. 8 squared is 64. 12 squared is 144. Add those together, you get 100. So 100 does not equal 144. It's not a true statement, so therefore this is not a right triangle. Therefore this is not perpendicular, so this would not be a tangent. We'd say no. Okay. Let's look at the bottom part. Now this is a new piece of information. This is something we need to know. If two segments from the same exterior point are tangent to a circle, then they are congruent. So this is the exterior point. We have two tangents here. We have AC and AB, and they're both tangent to this circle. Because they're both tangent to the same circle and they have the same point of origin essentially, that means they have to be the same length. So AB would be congruent to AC. That's important. We have to be able to use that. So for example, check this out. We have a circle, and we have an exterior point, and we have what looks like two tangents. So what we're doing is we're going to solve for the lengths of those tangents. Well, we know they have to be the same length because they're both coming from the same exterior point, and they're both tangent to the same circle. So we can solve this algebraically. We know their lengths as described by an algebraic expression, so we can set them equal to each other. So we're going to say 3y plus 5 is equal to 2y plus 6. We're going to subtract 2y from both sides. So we have y plus 5 equals 6, subtract 5. Y is equal to 1. But it's not asking us for y, it's asking us for the actual lengths of those tangents. We're going to plug y back in. So we have 3y plus 5, 3 times 1 plus 5, 3 plus 5, and that is 8. So this should be 8 as well. Let's see if it works. 2y plus 6. 2 times 1 plus 6, 2 plus 6, 8. Yep. So they are indeed the same length. So that's really the only last part we had in regards to tangents. I hope that helps. Let me know if you have any questions. Thanks, guys.